We have put safety measures that anytime the road is, they see anything developing, they close the road immediately.
A massive crack in the ground that's estimated to be up to 50 feet deep has opened up in Kenya seemingly overnight.
Some parts are pretty scary, like here, which is wider than 20 meters.
Politics and country borders change all the time, but the planet's physical layout was assumed to be permanent, right? Throw away your globes, for the world of geography is about to get fascinating. We are not talking about erosion or your typical volcano outburst. We're talking about how the wheels are in motion for the formation of a brand new ocean right in the heart of Africa. Around 200 million years ago, the supercontinent Pangea, which covered the whole territory of Earth, began to disintegrate. The now separated landmasses eventually separated to form the present continents, as well as the Atlantic and Indian Oceans. Scientists are now predicting the formation of a new continent when Africa splits. Right now, the tectonic plates are steadily separating apart and will eventually separate to produce a new continent and ocean in Africa. When will this happen, and how serious is the situation? Stick around to the end as we go through this one in detail. It's possible to stand on the precise point where the continent is splitting apart deep underground in one of the hottest places on Earth, along an arid stretch of East Africa's Afar area. This lonely stretch stands above the confluence of three tectonic plates that are slowly ripping away from each other, a complex geological process that scientists predict may split Africa in two and create a new ocean basin millions of years from now. For the time being, the most visible evidence is a 35-mile-long fracture in the Ethiopian desert. The tectonic fate of the African continent has been researched for decades, but new satellite data are helping scientists better comprehend the shift and providing crucial tools to investigate the gradual emergence of a new ocean in one of the planet's most geologically unique locations. Christopher Moore, a PhD doctorate student at the School of Earth and Environment at the University of Leeds in the United Kingdom, could see the red haze of lava flows a few kilometres distant while standing close to a lava lake at the summit of a large volcano. This may appear to be an unusual sight, but at Ethiopia's Erta Ale, it's business as usual. This is the only place on Earth where you can study how continental rift becomes oceanic rift, said Christopher Moore, who has been using satellite radar to monitor volcanic activity in East Africa that is related with the continent's separation. The formation of Africa's new ocean is expected to take at least 5 million to 10 million years, but the Afar region's advantageous placement at the boundaries of the Nubian, Somali, and Arabian plates make it a unique laboratory for studying intricate tectonic processes. The crust of the Earth is made up of a dozen enormous tectonic plates, which are irregularly formed rocky slabs that constantly crush against, climb over, slide beneath, or stretch apart from one another. The Arabian plate has been sliding away from Africa for the past 30 million years, resulting in the formation of the Red Sea and the Gulf of Aden between the two connected landmasses. But in East Africa, the Somali plate is also separating from the Nubian plate, tearing apart along the East African Rift Valley, which runs through Ethiopia and Kenya. But there are still some significant unknowns, including what is causing the continent to drift away. Some believe that the region's continental rift is being driven by a large plume of superheated rocks erupting from the mantle beneath East Africa. The crust of the Earth is made up of a number of plates which move across the mantle, which is the rocky inner layer that is located above the core of the Earth. There are 9 primary plates, and each one receives its name from the type of topography that is found on top of it. Plate tectonics refer to the process through which the Earth's plates move apart and together as a result of convection, which occurs when hotter material near the Earth's core rises while cooler convective rock sinks. The exact motion of the tectonic plates is still a topic of intense investigation and debate between scientists. Plates tend to draw apart near mid-ocean ridges, which results in spaces being created between the various tectonic plates. The plates continue to move apart as a result of the expansion of magma at the ridges, which results in the formation of a new ocean crust. Volcanoes and other natural phenomena, such as the San Andreas Fault in California, are also caused by the movement of the tectonic plates that underlie the Earth's crust. How does a new ocean form? scientists are using new satellite measurements to better understand how the plates in Africa are moving and to examine the slow development of a new ocean. Aside from the 9 primary plates, the Earth's crust is made up of a dozen huge plates that are constantly moving, mashing against each other, climbing over, slipping under, or stretching apart. For the past 30 million years, the Arabian Plate has been sliding away from Africa, resulting in the formation of the Red Sea and the Gulf of Aden. Along the East African Rift Valley, which runs through Ethiopia and Kenya, the Somali Plate is likewise stretching away from the Nubian Plate. Scientists are still unsure as to what is causing these plates to separate. According to one scenario, a giant plume of superheated materials is emerging from the mantle beneath East Africa, accelerating the continent's fissure. Over the last few years, advanced GPS sensors have enabled scientists to obtain precise measurements of how the ground moves over time. With GPS measurements, you can measure rates of movement down to a few millimeters per year, said Ken McDonald, a marine geophysicist and professor emeritus at the University of California, Santa Barbara. As we get more and more measurements from GPS, we can get a much greater sense of what's going on. Cynthia Ebbinger, a geophysicist at Tulane University in New Orleans, has led several field study expeditions in the area. She has researched the 35-mile gap that popped out in Ethiopia's desert in 2005. She claims that the break was the equivalent of hundreds of years of tectonic plate movement in a few days. Her research has revealed that the rifting process is not always smooth and does not occur at a constant rate. Sometimes, as is the situation in Ethiopia, there can be some powerful, unexpected jerks. She believes that growing magma pressure is generating explosive eruptions like the one in Africa, much like an overfilled balloon that could rupture at the least touch. We're trying to understand the straw that breaks the camel's back, she explained. Ebbinger believes that rising magma pressure is causing the explosive episodes recorded in the Afar region. She compared the situation to overfilling a balloon, which creates so much strain on the outside that it doesn't take much to alleviate the pressure and cause the balloon to pop. These rifting occurrences will change the African continent over time. Each plate boundary in the Afar region is spreading at a different rate, but the combined forces of these separating plates are forming a mid-ocean ridge system where a new ocean will eventually form. The Gulf of Aden and the Red Sea will flood in over the Afar region and into the East African Rift Valley and become a new ocean, and that part of East Africa will become its own separate small continent, McDonald said. The 3 plates separate at various rates. According to McDonald, the Arabian Plate is separating from Africa at a rate of around 1 inch per year, while the 2 African plates are separating at a rate of 0.5 inch to 0.2 inch per year. The rifting process may be moving at a snail's pace, but researchers claim there are definite indicators that it is happening. As the plates separate, material from deep within the Earth rises to the surface, forming oceanic crust at the ridges. We can see that oceanic crust is starting to form because it's distinctly different from continental crust in its composition and density, Moore said. What causes a continent to split? Why is this location such a hotspot for rifting and spreading? One theory is that the Afar plume has been heating the area from below. This mantle plume caused the African continent to rise and split, resulting in rift valleys. A huge mantle plume appears to be linked to the formation of new continental rifts and eventually 2 passive continental edges separated by seafloor spreading at ocean ridges, similar to how the North Atlantic Ocean opened 80 million years ago. Geologists have long been able to distinguish distinct tectonic settings and plate borders. For decades, extensional, divergent, collisional, and transform borders have been identified. It is less clear how one barrier transitions into another. At what point does subduction begin at a passive margin? What occurs when a spreading center is drawn into a subduction zone? When does a continent's rifting result in the formation of a new ocean basin? These questions are difficult to answer because there are few recent examples of these tectonic changeover stages. How can we tell when a rifting continent transforms into a new ocean basin? Continental rifts are not all the same, and some fail to produce true oceanic spreading. The mid-continent rift, for example, was the location of a failed effort to separate North America some 1.1 billion years ago. Dr. James Hammond, a seismologist from the University of Bristol who has been working in Afar, claims that parts of the region are below sea level and that the ocean is only separated from Eritrea by a 20-metre block of land. Eventually, this will drift apart, he told the BBC World Service. The sea will flood in and will start to create this new ocean. It will pull apart, sink down deeper and deeper, and eventually parts of southern Ethiopia, Somalia will drift off, create a new island, and we'll have a smaller Africa and a very big island that floats out into the Indian Ocean. The researchers consider themselves extraordinarily fortunate to have witnessed the birth of this ocean, considering the process is generally shrouded beneath the seas. The team hopes to undertake experiments in the area that will help them understand how the Earth's surface is shaped. They hope that studying the Earth's formation will help scientists better comprehend natural risks such as earthquakes and volcanic eruptions. Let's hear what you have to say about this forming new ocean in the comments section.